13.1 had us starting out as looking at periodic functions. So a function is periodic if the x and the y start to repeat. So this function, although it's not drawn great, it's periodic because there's a pattern to it with the x and the y. So you can check the period on the x-axis by checking out the distance between two similar points on the graph. So you could check this distance, and this would be the period, which would be the same thing as this distance from here to here. Or you could also check at other points on your graph. So this point matches up with this point, and these all should be the same. So x would be the period, the distance on the x-axis. The amplitude is half the height of the wave. So what you have to do is you have to measure the distance by looking at the scale and then taking half of that distance. So to draw something with, let's sketch a sound wave. So sound waves look like this. Sketch a sound wave with a period of 8 and an amplitude of 2. So what you're going to do is if your amplitude is 2, what I think the easiest way to do is to go up 2 and down 2. You could always start at 0 and go up 4, but half the height is going to be 2. Then I take the period 8 and I cut it into fourths. And what I'm going to do is I'm going to start in the middle and I'm going to go up. So I go to the max, I go to the 0, I go to the min, I go back to the 0. And I keep going up, 0, min. So therefore my period is from 0 to 8 because it starts repeating itself right here after 8. And it's going up to 2 and down to 2, so the amplitude is 2. But I think it's easiest if you cut the period into 4 spots and do a 0, max, 0, min, 0. This is a sound wave, and it actually is also a sine wave. Later on we're going to graph y equals sine of x, and this is an example of what it looks like. You also need to know how to use the unit circle to find exact values. So if you want to find cosine of 150, the coordinate, and sine of 150 degrees. Remember, cosine refers to the x-coordinate and sine refers to the y-coordinate. So if I set up my 150 degree angle, so I'm going to start right here and go up counterclockwise 150 degrees, and I'm going to be 30 degrees short of 180. So the reference angle is going to be a 30-degree triangle. Now, in the unit circle, the radius is 1. So here's 1. And in a 30-degree angle, the side lengths are opposite the 30 is 1/2, and opposite the 60 would be root 3 over 2. So if you're trying to find the cosine of 150 degrees, you're looking for the x-coordinate. You're trying to find this coordinate right here. What is the x and what is the y at 150 degrees? So the x-coordinate, you have went left root 3 over 2. So the x-coordinate is going to be negative root 3 over 2. And the y-coordinate, you have went up 1/2. So I'll do another one over here. So let's do the cosine of 225 and then the sine, find the exact value. So without a calculator. So what you do is you do 225 degrees. Start right here, you're going to go counterclockwise. And how many degrees is it from 180? Well, you have to go 45 degrees more. So this reference triangle ends up being a 45-degree angle. So in a 45, the hypotenuse is 1 in the unit circle. This is root 2 over 2, and this side's root 2 over 2, this distance. So if you're trying to find the coordinate, the x and the y is the cosine of 225. So that's actually you're going to go back root 2 over 2. So this is going to be negative root 2 over 2. And then you're going to go down root 2 over 2, so that's negative root 2 over 2. Also, make sure that you can convert between degrees and radians. So in a circle, there are 360 degrees around here. Okay? So in the unit circle, the radius is 1. So another way we can talk about a measuring device for angles is what's called radians. Radians are almost always measured in terms of pi. So a radian, so all the way, if the circumference of a circle is 2 pi r, the distance around this circle, the circumference is 2 pi. So 2 pi is the same thing as 360 degrees. Therefore, pi is equal to 180 degrees when we're talking about radians. So you're going to use this ratio to convert from degrees to radians and radians to degrees. So if I have 300 degrees and I want to convert that to radians in terms of pi, what I'm going to do is I'm going to multiply 300 times pi over 180. And you're going to want to reduce. So I'm going to reduce 300 divided by 180, gives me 30/18, which reduces to, I can divide both of those by 6, so it's 5 pi over 3. If I had negative 120 degrees, I'm going to take 120 degrees and multiply it by pi over 180. These two cancel out, and I'm left with 12/18, which reduces to, I can divide both of them by 6 again, 2 pi over 3. This is all without a calculator. And you can also convert from radians to degrees. So if I start out with 3 pi over 4, in degrees, I'm going to do 3 pi over 4, but now I'm going to multiply it by 180 over pi. So the pi's cancel out. And what I would do without a calculator, I would divide 180 by 4 first, which is 3, or 45, and I already I think in 3. So this is 45 degrees, and you'd multiply 3 times 45 to give you 135 degrees. So I'll do another example. So if you have negative pi over 6, to convert it to degrees, what you do is you multiply it by the ratio of 180 over pi. These two cancel out. So 180 divided by 6 is 18 divided by 6 and add a 0. So that's negative 30 degrees. So you can do exact value with pi too, with radians too. So if you have to find the coordinate of cosine of negative 45, oops, I didn't mean to do that. I need to do cosine of, let's do negative 5 pi over 6, and the coordinate of sine of negative 5 pi over 6. So you could think of, what is this in degrees? What is negative 5 pi over 6 in degrees? So 5 pi over 6 is, to change it to degrees, I'm going to multiply it by 180 over pi. These two cancel out. So it's 30 on the top, so 5 times, this is a 5. 5 times 30 is 150 degrees. So now what you're doing is you're doing the same thing as doing the cosine of 150 and the sine of 150. Find the exact value. So you're going to set up your reference triangle, or your reference angle. So 150 is right here. This is it's negative 150. Oops. So you're going to go down 150 degrees this way, so which is going to give you almost to 180. So you make your reference triangle. This is going to be 30. And opposite the 30 is 1/2. And opposite the 60 is root 3 over 2. In a 30, 60, 90. So now in this quadrant, your x, you had to go back root 3 over 2. So it's negative root 3 over 2 as your x coordinate right here. And your y coordinate is negative 1/2. You can also find arc length using radians or degrees. So if you have to find the length of an arc, so the arc is this distance. So all the way around is the circumference. But an arc is just taking part of the circle. So if you had this picture and you're trying to find the length of that arc, and this was 10 centimeters, and the angle was, we'll do 50 degrees. If it's in degrees, what I would do is I would take, okay, what percent of the circle am I using? Well, I'm using 50 over 360 of this circle, because there's 360 degrees and I'm in degrees. And then I'm going to multiply it by the entire distance around the circle, which is 2 pi r. So 2 times pi times 10. So if I want to reduce, I have 10. Those two can cancel out, and then I can reduce 236 to be an 18 on the bottom. And I could keep going. This I could divide by 2, and this could divide by 2. And I'm left with 25 pi over 9 centimeters as my answer. So if I'm doing degrees, I would take the degree over 360 and multiply it by the circumference. If you're given radians, I would use this formula. Arc length equals theta. So theta is the degree measure in radians, or the angle measure in radians, the central angle, times r, which is the radius. So I'm going to do a similar circle. The radius is 20 centimeters. And then we're finding this arc. And this is pi over 3. Radians is the measure. So I just use my formula. S equals the measure in radians, which is pi over 3, times the radius, which is 20. So my answer is going to be 20 pi's over 3 centimeters. So it's a distance, so it needs to be in centimeters.